Hello and welcome. In this video, we'll be representing and we'll be finding out and calculating missing components of parallel vectors. So let's get into it. In this example, we've been given that A is 5i plus 2j, B is 3i minus 4j. We are calculating what is 2a minus b. So all you have to do is multiply out 2 with components of A and subtract components of B from it. So that's going to be 10i minus 3i. So 10i minus 3i will be 7 and 4j, 4 minus 4j will give us 8j. Alright, so I'm just explicitly multiplying out the bracket here, so you can see that minus a minus 4 makes a plus 4, and that's why we get 7i plus 8j. Alright, if you try to do this too quickly, you might have made an error. It's up to you. Alright, so in the end, we can rewrite these vectors as column notations as well. So this would have told you that you get 10i minus 3i and 4i minus 4j. Okay, so let's understand this question here. In this question, I think this is also one of the last examples I have for you. So it's worth noting this down and just working through it slowly. We've got two vectors. Vector 1 is 2i plus 5aj. A is a constant here. And vector v is ai minus 7j. Now this constant a is missing out of the two vectors here. It says find the resultant vector r in terms of a. Alright, so it means don't worry, we know a is missing, but just write the answer. So we're gonna add them component wise. We will get 2 plus a in I direction, and we'll have 5i minus 7j, 7 in j or in y direction. Now in the next part of the question, this should be part B, not A. So what values of a will make are parallel to, so this vector that we found there, resultant vector, what value of a will make it parallel to 3i 32j? Calculate the exact value of r after. So we need to figure out what a is if it's parallel to 3 and 3i and 32j. So what does it mean for these vectors to be parallel to each other? If I picture this for you, it means that the ratio of the sides, this ratio of 3 to 32, must be the same as the ratio of that bracket in front of I to that bracket in front of J. So if I picture this for you, they pointing the same, parallel means that they have to point the same direction, right? So if you imagine I is the x axis here, and this is the x axis, so I is running in the x direction. So this angle here, theta, is the same as that angle there, theta, because we've been told that we want them to be parallel. So that means the tangent of the tangent of this theta is the opposite over adjacent, isn't it? And we're not concerned with the hypotenuse of this right angle triangle here. So we say that if tan of these two angles is the same, the ratio of these sides are the same. So I've taken j on the top of the fraction. I put i's in the bottom, so that would give me literally the tan. But it wouldn't be wrong to write it other way around. It doesn't matter if we're not actually calculating an angle here. We're just looking for this, solving this equation. Setting these two fractions equal to each other means doing this and cross multiplying and solving for a. Alright, so once you cross multiply it and try to solve it for a, you collect like terms on one side of the equation, and you will end up with a being minus 5. Alright, now that we know the value of a, we can substitute it back into this definition that we started with, this this definition because they say calculate the exact value of r. All right, so was 2 minus 5 minus 3, so that's minus 3i, and 5 times minus 5 is minus 25 minus 7, so that's minus 32, I believe, J. All right, so let's see. Yeah, here's the working out. So minus 3, yeah, exactly. When you I just put them back into the original. This is V1 and V2. I should change the names here. And then added them together. It's the same answer that I got for you up there. I just used the definition that was quicker because we already had added these up. So using this definition of R would have been quicker. Right, so this is the only example I have for you with regard to finding parallel components of parallel vectors. I've tried to even, yeah, this is, I think, complicated enough to understand when two vectors are parallel to each other, the ratio of their components is the same. This doesn't mean that the components are the same. So notice I didn't say some students, this is the error they think. They say 5 a minus 7 must equal to 32. This is not what I said. I said the ratio here is the same, equals to the ratio there. I didn't say 2a 2 plus a equals to 3. Okay, so don't confuse that. This is a common mistake my students sometimes make. All right, so good luck practicing, and you can, there are some challenging questions there, and